All right, so today's lesson is kind of incorporating the some skills that we've been looking at over the last couple of days, but we're going to be focusing on finding missing values of x for angles. So if you're given measurements of an angle, so if we see an example one, and guys, we're on page 14 of our paper packet. If you'd like to take along or take notes along with us, it could be really helpful to reference when you're completing the practice activity or you're taking quizzes later on. So I do encourage you to write this down with us. So on page 14, you see example one, and it gives us an angle, which tells us in the problem that the angle of, or the measurement of angle B is 140 degrees. If I take out my protractor, that's its measurement. It also, in this problem, gives us a variable expression of 5x to represent the angle. So we've kind of got two different ways the angle is labeled, but we know they're referring to the same angle, right? And those values are equal. They're the same. They're just written differently. So we could set up an equation if we are asked to, again, if we look at the directions here, we're finding the value of x. So in order to do that, we know that that expression, 5x, is equal to 140. They're referring to the same exact measurement of that angle. So once we have our equation set up, solve through that one-step equation, we would divide on both sides by 5, and we get the answer of, let's see, 140 divided by 5 is going to give you the answer of 28. So the value of x in this problem is 28. Now you could always check your work, right? We have 5x was our variable expression. That should be equal to 140. So if we have 5 times x, or 28, it should equal 140. If we do the math, we do get 140 equals 140. All right, so if you take a look at example 2, example 2, we're looking at angle H, and it tells us in our problem it is 44 degrees. We also have the variable expression of x minus 34. And again, those are just two different ways to talk about that angle of H. So if we're asked to find the value of x, we know that they're equal to each other. So we would take 44 and set it equal to our expression. And again, guys, you might say like, I like the expression to be on the left. That's kind of the more typical. It is up to you how you guys write it. So if you want to write the x minus 34 first and put my solid one answer there on the end, it's kind of the more typical way to see it. By all means, write it how you're comfortable. You're in charge of it. Solving this equation, one-step equation. So to undo subtraction, we use addition. So we're going to add on both sides 34, and we get x equals 78. Again, you could kind of quickly check your work. We have x minus 34 should give us 44. So if you took a minute, 78 minus 34, we did the math. It does actually do indeed give us 44. So again, when you're looking at equations, the nice part is you can always check your work. All right, example 3 here. It says our measure of the angle J is 84 degrees. Again, this angle is 84. It also tells us another way we could look at that angle or label that angle is by 2x minus 8. Those values are equal to each other since they're both referring to the measurement of angle J. So I could write my equation. Now this one's a two-step equation, but we do addition, subtraction first, and then undo multiplying and dividing. So as we would add first, we get 92. Then our second step is we would divide each side by 2. And we get x equals, oh, I wrote outside the box there. X equals 46. All right, so the second, the back side on page 15, you see similar problems. But if you take a look at this one, number 1 here, we have the angle measurement is unknown. It doesn't tell us. It actually doesn't even have a label for this angle. It's just a generic angle, but it does tell us an expression. 2x minus 6 is the only thing we know about that measurement of this angle. Now we do have protractors, and it is a visual picture. So I can use a protractor to find the measurement first of my protractor and then set and solve an equation. So again, using my protractor, I put the vertex right on the cross of the sun, make sure that one of the angle sides is out or along the horizon, and then kind of working my way up. Again, I'd use the inner track of numbers because I always start at 0. and this measurement is at 75. Now you guys might also, it's a little harder for me to do, but do you see how that whenever we had it lined up, my line doesn't quite touch where I need it to. So again, you can always use that protractor as a straight edge. And again, I'm going to struggle here. You could draw yourself probably a straighter line, but again, you could extend your line if you need to. And that way, when you line up your protractor, it nicely comes out and touches the measurements, so it's a little easier to read. So now we can kind of see it's clearly at 75 degrees. So I gave you a space to write down your measurement, which in this case we said was 75. Once we know the actual measurement of the angle and the expression, same kind of idea. We would take that expression. Again, I know a lot of you like the expression first and then your quote answer on the right-hand side. So you can be in charge of how you write it. Working our way through this two-step equation, we add 6 to both sides. If I divide by 2 here, you get the answer of 40.5. And again, decimals are okay, guys. It looks like there's a million decimals in this problem here, but your answer is 40.5. And there is some degree of error when you're measuring with a protractor. So again, you may find that you get a little bit of decimals here and there, and that's okay. 2 more examples to complete with you. So again, you look at example number 2, we are only given an expression and we're asked to find x. So the other bit of information I need is the actual angle measurement. So lining up my protractor, the vertex right here on this cross of the sun, moving out along the horizon. Again, I'm using the inner track because I start at 0 when I'm counting. Moving our way out, this one's like right between 130 and 140. So, all right, so we're going to choose 137. And again, I know that there might be some discrepancy in your measurements. And again, I would take anything in between, 135 and 140. Now, if you're telling me your measurement angle is 40, then we have a problem, right? But as long as you're using the right track, and if you're a little bit off by a couple degrees, no big deal. So once you have your angle measurement, you're going to set up your equation. X plus 17 is equal to 137. Solve using opposite operations. And we get x equals 120 here for the second one. Last example. Hopefully you get the hang by now. Again, we only have an expression there for trying to find x. The other bit of information I need to know is my measurement of my angle. So lining it up here, coming out to the 0, counting on up, it is about 35. And again, if you guys need to extend the line first before you put your protractor down, a little bit easier on paper. I already forgot my measurements. One looks like 36. So once you have that information, you can go ahead and set up your equation. Solving through, we divide to get rid of that multiplying, so we get x is 6 for this last one. And again, I can encourage you, check your answer. You can plug it in. So like for this top example, we could plug in a 120 in for our x. 120 plus 17 does give me my measurement of 137. Same for the bottom one, 6 times x, 6 times 6 is what we said our answer was, is actually 36. So, depending on how you measured, your work should still check out. So that's a way for you to check and make sure that you did your work correctly. The assignment is super similar to the note sheet. It's the next 2 pages in your packet that I want you to go ahead and complete and submit a picture of for a grade. So you're looking at submitting pages, let me just give you a page number here. You're looking at submitting pages 16 and 17. Reach out if you need any help. Good luck.